Alright, welcome Algebra 2. Today should be Tuesday. So we've been working this chapter on simplifying expressions and solving equations. So we've learned a lot about rational expressions so far. We learned how to simplify complex algebraic expressions by factoring numerators and denominators yesterday. And we have learned how to multiply and divide rational expressions. So today we get to develop a method to help add and subtract algebraic fractions. So this first problem here says to reread our directions from the homework problem 3-92 from yesterday and make sure everyone had the same answer. So this is one where it asks us to write out step-by-step directions for 1/3 plus 2/5. And then it goes, Monica's sister now wants to know why. Why does she have to do all those steps with a common denominator? What is a fraction anyways? And why does adding them have to be so complicated? So it wants us to draw pictures and make up a situation that will help to know what fractions like 1/3 and 2/5 actually mean. So my first initial thought when I think of this is to do something like drawing a couple circles and say, all right, suppose I have 2 pizzas. I have 1/3 of one pizza left. And let's see, how am I going to split this into fifths? Let's see, you got 1, 2, 3, 4, 5, something like that. 2/5 of another. But the question is, if I wanted to know how much pizza I have left, how much is this? If I wanted to know how many slices that is, I could say, okay, sure, it's 3 slices, but I have 3 like completely different sized slices. So if I wanted to know how much of a single pizza do we actually have left, there's no way to see it really with doing a pizza with 3 slices and adding a pizza with 5 slices. So that's where we need those common denominators to add these properly. And that's where then we can show that, oh, we need that 1/3 to show that this is going to be the same in this case as 5/15. 2/5 to show this is the same as 6/15. So that way when we add them, we get 5/15 plus 6/15 to give us that 11/15. Now I know this is stuff we learned how to do back in like 5th, 6th grade. So the thing is though, is just like we need the common denominators with numbers, if we're doing algebraic fractions, so rational expressions with algebraic fractions, we need a common denominator in order to add these still. So if I want to add these, the first thing I need to do is get that common denominator. So the way I can do that is just like how, let's change my fold a little bit. Up here, 1/3 plus 2/5, I can get the common denominator 15ths easily by saying 3 times 5, multiplying my 2 denominators together. So I'm going to do the same thing here. For my common denominator, I'm going to multiply and make my common denominator x minus 1 times x plus 5. So my first fraction will become 2x times x plus 5 over x minus 1 times x plus 5. Those can cancel and reduces back to what I had. That's fine. And then for the other fraction, I'm going to do 3 times x minus 1 over, again, that gives me x minus 1 times x plus 5. All right, sweet, but currently this just looks even more complicated. So we do need to distribute 2x squared plus 5x. And I'm just going to kind of combine it all at once, 3x minus 1. So I have my first fraction, my second fraction, since they have the same denominator. When I add them, the denominator stays. And I can do one last step on simplifying. 2x squared, 8x minus 1, x minus 1, x plus 5. And we're all set and happy. 2x squared plus 8x minus 1 over x minus 1 times x plus 5. Sweet, so we have a process for adding fractions. Yes, even when you're not here, the bell still goes off. It gets kind of annoying. We really should be, though, when we're adding them, be double checking, make sure whether or not our numerator can be factored. So, I think this one does it. Let's go through A as well. We already have the 3x plus 1 in both fractions, which is a good sign. That means all I have to do is multiply this first fraction by x minus 5 over x minus 5. So I get x times x minus 5 over 3x plus 1 times x minus 5. And then we're adding 2x squared minus 2 over x minus 5 times 3x plus 1. So the order we multiply in doesn't matter. So for our denominator, 3x plus 1 times x minus 5 is indeed the same as x minus 5 times 3x plus 1. So if I distribute these, I get x squared minus 5x, and then again plus 2x squared minus 2, all over x minus 5, 3x plus 1. Whoops. All right. X squared. 3x squared, 1x squared there, 2 more there, minus 5x minus 2. X minus 5, 3x plus 1. All right, so from the last problem we just said, hey, we're done at this point, but we really should still be double checking, does this factor? And in this case, we will find it does actually. So if I set up the box that we did for factoring, 3x squared in one corner, negative 2 in the opposite. We're looking for two numbers that multiply to negative 6x squared and add to negative 5x. Now, I'm hoping and thinking that we should be able to figure out that, hey, negative 6x and positive 1x will multiply to negative 6x squared, and these will add to negative 5x. So negative 6x in one corner, positive 1x in the other. So I get 3x there, a 1x here, which means I'm 1 there minus 2 there. 3x plus 1, x minus 2, over x minus 5, 3x plus 1. So we have it in factored form now, fully factored top and bottom. And this is where we need to make sure if we can factor the top that we do so. Because we find one thing now happens. My 3x plus 1 over 3x plus 1, those cancel out. And this reduces even more, x minus 2 over x minus 5. Done. I should make that more legible. Minus 5. There we go. So x minus 2 over x minus 5. This is what we're going to want to continue to do for part B there, as well as then for 100. For 100, my one hint for this, it gives us two quadratics on the bottom. I would factor these first. Because what if I'm going a little bit off memory here, but if I remember correctly, what happens here is that we'll find one of the factors is the same already, So we don't necessarily end up needing to make them too crazy. If we just leave it all factored, it'll actually be a lot easier to do this than multiplying both sides, say by x squared minus 3x minus 28, or one top and bottom here by that x squared and then top and bottom by the other one. It just gets all messy. So I would factor these first and then look at your factors to come up with the common denominator. All right, I will leave an answer key for this for the sub. So if you have any questions, you can check with them, and I will hope you do okay on this. And don't forget you have the test on Friday, and we'll have one more video for tomorrow. Thanks, bye.